Now welcome back to the channel, hope everybody's doing well, and in today's video we are taking a look at the LCR-300 LCR meter from Voltcraft. If you've never heard of Voltcraft, they are the in-house instrument brand for Conrad Electronics. Conrad Electronics are an electrical/electronic supplier based in Germany. They're actually established way back in 1923, so over 100 years old now, as an electronics store in Berlin itself, and they are still a family-owned business, I believe. And they are Germany's equivalent to RS Components in the UK or Newark in the United States of America. Now, whilst this is their own in-house brand, I do not believe they actually manufacture this instrument themselves. I believe it's made on behalf of them and is in actual fact the VA 520 LCR meter from the Shanghai VA Instrument Company. The Shanghai VA Instrument Company is part of the Rishab Group since 2020, Rishab Group being of Indian origin, and they have the Rishab instruments within that group. As far as the Shanghai VA Instrument is concerned, that actually started out life way back in 2001 as the V&A Instruments Company in partnership with Mastek, and I'm sure a lot of people have heard of Mastek Instruments, another Chinese manufacturer that make an awful lot of rebrands. So that's what we've got sat in front of us. The whole package that you see here comes in this little box that we've got here, and then inside the box we have the instruction manual itself, and then we have the pouch here. It's got like a protective built-in layer on the front and on the back here as well. Inside we've got the little pouch here for the instruction manual or the leads should you want to put them in there. The leads themselves are Kelvin leads, so we've got a dual connection for each lead, and we also have a guard connection as well, red and black there. And then we do have a little standalone lead for guard connection should you need to use that with some of your test setups. We do have a shorting strip for doing the calibrations with, and then we have the actual meter itself. So we put that all to one side. This little lot here will set you back currently around about €210 on the Conrad Electronic website. That's equivalent to around about £183 in the UK or $244 in America. So to look at the manual itself, it's a multilingual manual. You see we've got 4 languages in there. For ease, I'm just going to turn straight to the English version. You see it's a pretty well laid out manual. You've got all the functions, how to make the measurements there, and then if we slip over to the back of here, we get the technical data. We get all the tables here of the accuracy and for each of the frequencies that you have for each of the functions and the relevant accuracy and resolution. So there are your tables there that you can work to find out which is the best setup for the component that you're trying to measure. So the instrument, in terms of its functionality, we can measure resistance from 0.001 ohm up to 200 mega ohms. We can measure capacitance from 0.01 picofarads up to 20 millifarads, and we can measure inductance from 0.01 microhenries all the way up to 2000 henries. Nominally at 1 kilohertz, all those functions there have an accuracy of plus or minus 0.3% to plus or minus 1%. If you widen out and use the higher frequencies that the instrument is capable of measuring to, that extends up to a 2% tolerance, again depending on what component you're measuring and its actual value. So we'll set the instrument up and turn him on. We do have here, it defaults to a 1 kilohertz operation and auto operation as well, where it will attempt to select the best function that it thinks it's trying to measure. To go through the frequency, we have the buttons here, and we can go from up to 10 kilohertz there, 100 kilohertz, and then we go back down to 100 hertz, 120 Hertz, and back to 1 kilohertz. So they're your frequencies that you can utilize with the instrument. We can use the function button here to manually force the measurement function, and once we have forced a particular function, we can then change the setup to how we like. So if we switch to capacitance here, we can then use the frequency button to change the frequency, or we can use the function to go through D there, Q now, and then RP, root parallel resistance, theta for the angle, and then back to D. If we change to serial parallel, we should be able to get equivalent series resistance as well. And there's our ESR measurement. Should we want that? Obviously that's just applicable to capacitance there. And then we also do have a relative function as well. So if we've measured residual capacitance or inductance, we can then do a differential from that. We can do a sorting function as well, should you want to look at a comparison of different values across a range of components. And we have our hold function as well, should we want to hold the reading. And that's pretty much the basic functionality of the instrument. We do have a light here as well, which is a fairly respectable light. It does seem to work quite well. We can turn him off again. So what we can do, we will turn him back to an auto. We will plug our leads, and you do have a calibration here as well. I'm not going to run it with that. You can calibrate it for use with either the slots here if you're plugging components direct in, which you would then use your shorting bar for, or you can use the leads themselves to do the calibration with. I'm also going to leave it switch to 1 kilohertz just for this little demo, and we will leave it in auto to start with to see how we get on. And we do have our DMMCheck Plus revision 8 that we can look at. So we will start with our resistances. So this should be 100 ohms. And we switched automatically to series resistance 99.98, which is very good, to 1 kilo ohm. And again, series resistance, we've got 999 ohms, 10k, 9.989 kilo ohms, so all good, I would imagine. And then we slip to parallel resistance, 99.73 kilo ohms there. Now we then move on to our inductance. We've got 1 microhenry here. We've remained in auto, and you can see it's actually stayed in series resistance. It doesn't like to pick up the inductance, so we can force this, go to function. Interestingly, it doesn't like that. What are you doing? So there we've stayed now in series inductance, and we've got stuck on 1 microhenry. We can move to our 10 microhenries. We've got 10.7, 100 microhenries, 107.2. Let's just see if we can get back to. See if we'll go back to auto. See if it'll pick up 100 microhenries. Capacitance, still doesn't like it. Thinks it's a capacitor now, so it doesn't do too well with inductance. Yeah, it really doesn't like it, does it? Back to our 100 microhenries, and here we've got 1 millihenry at the end. We've got 1039 microhenries there. And we'll flip him around, we'll take him back to auto, and we'll go for our capacitance, see if we can get him in auto. Yeah, that should be no, that's 1 microfarad, I beg your pardon. And we have picked up 1013 nanofarads, so that's good enough for 1 microfarad. We'll go to 0.1 microfarad. Sorry, going the opposite way with these ones. and that is 101 nanofarads, which is correct, 0.01, so it should be 10 nanofarads here. 10 nanofarads, so it can pick up the resistance and the capacitance in auto mode fairly well. And finally 1 nanofarad, which is picked up as 963 picofarads. So yeah, we can pick up our capacitance and our resistance okay in auto mode, but to get to our inductance we generally have to set the function up manually, and then it will work perfectly okay. So we can just put this little results table up here for the measurements that we made on the DMMCheck Plus. You can see the vast majority are all within tolerance. However, our 1 microfarad and our 1 millihenry are out of tolerance. Along with the 10 microhenry, that's very close. It's not quite out of tolerance, but it is very, very close. It's always done this on this DMMCheck Plus. I don't know the reason why. Just to the side of this is a smaller table with the uncalibrated measurements that you saw me take against after you've actually calibrated the unit with the little cal function here, and you can see there is no real difference between the measurements. So it's always been like this throughout the whole of the history. It's a consistent set of readings that those two are always out, and the 10 microhenry is very, very close. So I need to spend more time with it really to see why it's doing that, compare it to other instruments. We can just look at the calibration function on here just to show you. It takes a full minute to calibrate the instrument. Yeah, you can see it like that. So you hold in the cal button for 2 seconds. It wants to do the open characteristic first, so you hit the cal button short press, and you can see it's counting down here from 30 seconds. So when it's done that, it will then move to the short. So it's done its open circuit test there. You can see it's passed it. So you hit the cal button again. It requests the short now, so we'll install the little short here that is provided with the instrument. As I said, if you're doing this with the leads, then you would just short the leads together. Short press of the cal button again, and it will start on its 30-second cycle. Again, I'll speed this up so we're not sat there watching it all the time. Again, once you've done the short, it comes back with the pass or fail. It's come back to pass, so we're all okay. So we can hit the cal button, remove the short, and then we are all ready to go. There is no indication once you have actually calibrated the instrument that the calibration has been carried out. You only know once you've carried it out yourself. Obviously, once you've turned the instrument off, you would need to recalibrate it if you want to go down that route again. But as I said, with the 3 measurements I've got that are slightly out, it's not made any difference to that at all. So that's our LCR-300 meter there, constructed quite nicely actually. This is all a rubberized coating around the outside here and along the bottom, and then you've got hard plastic on the grey part here, and this black part here where the test leads are plugged in is also hard plastic as well. It does take 6 AAA batteries that go into the little compartment in there. Take the screws out for that one. And these are self-tappers in here, and as you can see they are not retained at all, so easy enough to lose. And then you come out. Just come eventually. So there's your 6 AAA batteries in there. You also have the option of running this from a 12-volt power supply that you can plug in there, external DC power supply. So you can plug that in and you can power it in that manner if you are working on the bench, which is quite handy to save on battery life, although I do say in my experience this is pretty good on battery life. Is open the instrument up so you can see inside what the score is with that aspect. There are 4 screws here, again self-tappers that are non-retained. Let's just have a quick deco inside, being a Chinese instrument, to see what the build quality is like. But I have never had any problems with this unit. So there's the meter itself. It will all fall out. Not quite sure why this cardboard is here. There's your 2 battery contacts there. It's not foil or anything, so it's not a screen, but it is just there. And there's the inside of the instrument. You can see here we actually suit hot melt glue on here, so I'm not going to take it any further than this, but it's a pretty respectable build really. There is a little bit of flux over here on some of the connections, but they all look fairly well soldered up. It is clean other than that. You can see those are two battery connections there, and then if I hold this up a bit close to the camera and it zooms in, you can see we've got the confirmation of our VA 520 serial number there, and I presume that's the fab date on the board and not a manufacturing date. To calibrate this, I presume it is a closed case calibration against an actual, where did he end up there? Factory calibration of the instrument, I should say. There is the cal button just up there, which aligns with this aspect of the case here, and then you've got the sticker over the cover of that to stop you pressing it, but I presume they've got a little carbon tool in there that just press down in there, and then you can carry the calibration out. But that's it inside. So there you have it. That's our LCR-300 LCR meter from Voltcraft. As I said, it's quite an old instrument to me now. Prior to me having the MTR-105, this is what I would utilise to measure the inductance of motor windings, and it's worked very well for that. But that'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.